Hello everyone, this is the video lecture for Pre-Calculus, section 4.3, Logarithmic Functions. That's a big name right there. Let's just do logs. Oops, probably needs an S. There you go, logs. So, what are they? What are we doing here? Well, they're the inverses of exponentials. So normally we'd have an exponential look like this. Exponential growth, let's say. Well, a log looks like this. There's a log equation. They're inverses. Again, they're symmetric about the y equals x line. An easier way to think of that is the 45-degree line. There you go. So I guess we can also see this as we got y equals b to the x as your exponential. The inverse of that would be y equals log base b of x. Again, these are inverses of one another, okay? They're inverses of one another. And so b is just a little subscript. Again, I'm assuming that you've seen this before, but, you know, it's good to have a review, let's say. Let's keep going. So I got 43004. Again, this is a graphing, match it up kind of question. So this here is a log base 2 of x. This side is a log base 2 of negative x. And then this guy here is a negative log base 2 of x. I'm not too concerned about it. Transformations, we've seen it before. No big deal there. Keep cruising. We got 43008. And so I've got... Oh, I remember this one. Okay. They got a box here, and they want you to rewrite these expressions in the opposite way. So we got log base 4 of 2 equals a half, and then a box. And then on this side, we got 4 cubed is equal to 64, and then a box over here. This is our logs, and these are going to be our exponentials. Okay. So what's going on here? Well, there's actually two, or I believe even more, of these on this one problem. So it's like a multi-part problem. Each line is independent of all the others. So like, you know, I'm going to be working with this line here, and it has nothing to do with the next one. It has nothing to do with the one after that. So, like, there's just a whole bunch of questions in one question. So, how are we going to go back and forth between these? Remember that I was saying that these are inverses. They're not the same. They're not equivalent. The reason why is because my y equals is right here and there. If you wanted the exact same thing, it's technically x equals log base b of y. These are equal to one another. Equal. These are equal. Literally the same thing. Notice that the format is that my x as an exponent is now on the outside. B is my base, still right there, but y used to be by himself. Now he's next to the b now, okay? So we're kind of like switching places with my x and y. I don't know, a few thoughts there. So let me do these problems if that's okay. I'm going to start with 4 cubed is equal to 64. And I want to rewrite this guy as log base 4 of something equals something, okay? I know it's a base 4 because, well, I got a base 4 there. That's one of the more obvious ones for me. The exponent is on the outside, and I don't know, maybe you can call it the answer is now on the inside. You're flipping where they are. I often like to think of this as friends. So notice that 4 and 3 are friends. Well, no longer. The 3 is now kicked out. He's outside. 4 and 3, they're no longer friends anymore. 64 was all by himself. He's kind of sad and all alone. Well, now 64 and 4, now they're friends. So it's not maybe friends, but like frenemies. Frenemies? I don't know. I don't even know how to spell that. The point, though, is that there's lots of different ways. I've heard of the swoop-de-whoops, and there's a lot of different ways to do this. You could just, basically, I'm moving it around in a certain way to make it look good. So my answer for this is going to be log base 4 of 64 is equal to 3. Another little small trick, which I think about a lot is that this number here is often smaller than this guy right there. Not every time. I'm not saying that's a rule. I'm just saying you could see that we're going down rather than up. Okay. What about this one? So we start with the log base 4 of 2 equals a half. And so I want to rewrite this. Well, I know that my base is 4, and I call this top of the tower off the island, whatever you want to call it. There's all kind of names for these things. But notice that 4 and 2 were good friends, but no longer. You're out of here, bro. Half was all by himself, but now he's found a friend. And does this make sense? Does this statement make sense to you? Is the square root of 4 equal to 2? And yeah, it is, actually. So we can even see that it is sensible when we get the answer, okay? Cool. Repeat, repeat, repeat. So however you want to do it, I'm just kind of showing you a couple ways. There's other ways, of course. Let's keep going. 4, 3, 0, 1, 2. So I'm going to start with part B, apparently, just because I can. Log base 8 of 4 is equal to 2/3, and they want to rewrite this as an exponential. Notice again, I got my base of 8, top of the tower, off the island. I say that because I'm thinking of like Survivor. That's kind of a TV show back a few long years ago. But anyways, it's kind of still in the pop culture phase, I think, or maybe they're still running. I have no clue. But I think like that because you're getting kicked off the island. You got friends, now they're enemies, and all that kind of stuff. Anyways, so the 8 and the 4 were good friends, but no longer. You're out of here, bro. 2/3 is all by himself. Now he's got a friend with the 8, and there's your answer. Super easy. I guess a lot of context behind all that. I'm not going to talk about Survivor anymore, but I will still use my analogy. I got 10 cubed is equal to 1,000. True. They don't care about that. They want you to rewrite it as a log equation. This is actually super easy. So I got log base 10. See, my base 10 is pretty easy to point out. Top of the tower off the island, I guess. So 10 and 3 were good friends, but no longer. You're out of here, bro. 10 and 3, they're not friends anymore. 1,000 was all by himself, but now you have a friend with 10. They both have a 0 at the end and a 1 in the front. So there you go. That's what you're typing into WebAssign. Now, some of y'all might be thinking, hey, how do I get that subscript in there? That is a great question. Of course, there's that little tab on the right side that you can click. You can either get a log or just a subscript button. I can't remember exactly what it looks like. It's maybe something like this, or maybe there's a log with a little subscripty thing. I can't remember. But regardless, what I always use is shift minus sign. Like on your keyboard, it's actually like, it's like underscore, or subscript, I guess you could say. So if you were to type that character, it would look like that. Like if you were to hold the shift key and just like all caps kind of thing. So it's the minus sign key on your keyboard, but this guy, and what it does in WebAssign is it drops it down. So like if you were to actually do that, it would like start dropping it down and you would type the rest right there automatically. And if you want to get out of it, you hit the arrow to the right key and it'll pop it back up like your blinking cursor, and then you can keep on typing and whatever it is. Okay? Just different ways of doing it. 43027. So I got A is equal to log base 9. I want to make sure you're seeing that. That's a 9, not an A, of 81 equal to blank. And we got 3 of these. I'm just going to do them in succession here. So I want to rewrite this in like my friend's exponential form. So I got a base of 9, top of the tower, off the island. Notice that 9 and 81 were good friends. No longer. You're out of here, bro. But box, yeah, that's a box. Box is all by himself, but now he's with 9. And so you're wondering what's inside the box. So we got like 9 to the somethings, 9 to the something power is equal to 81. And I'm thinking, well, 2. 9 squared is 81. So what's inside the box was a 2 the whole time. Sometimes I make funny jokes about like UPS and FedEx and stuff like that. And what was that one movie called? Can't even remember where. Anyways, So old, you probably wouldn't care anyways. Moving on. So, same thing here. I have 7. I guess you could just say to the box. Top of the tower off the island. I won't do this every time, I guess, maybe. 7 and 49 were good friends, no longer. Now Box is all by himself. Now he has a friend. So 7 to the box is equal to 49. What goes inside the box? Well, it's 7 squared. 7 squared is 49. And lastly, we got log base 8 of 8 to the 10th. This is actually kind of funny. I could do this without any other math. It's super easy. Cancel your 8s, you get a 10. You're done. This canceling is legitimate. If you get the same number as your base for, I guess, both of them, you cancel it out, and there you go. Later on, we might be talking about this here pretty soon, but like, say you just have like log of, I don't know, 10 cubed. Notice that it doesn't have a base, so that's a common base of 10. You can cancel. I don't know why I said 2 and I wrote a 3. Whatever, 3. And it also works backwards. So if you got a 10 and then like log 3, something like that. Well, again, that log, if it doesn't have a base, it's technically a 10, and they cancel, and you get your 3. Same thing with 8s, 10s, 5s, 1s. I don't think a 1 would work, regardless. Moving on. Maybe I talked too fast about all this. 4.3.032. This is the classroom experience, though, of course. E to the power of ln of the square root of 6. Remember that canceling stuff I was talking about? Well, ln is technically, I'm going to rewrite this only one time here, log base e of the square root of 6 there. Well, e's cancel, and you're left with square root 6. So e and ln will cancel, okay? E and ln cancel. I think I'm skipping ahead to part C here. I got 10 to the log of 11. Yet again, I already know if there's not a base, it's base 10. They cancel. You make the 11. So I guess I was preemptive on that. Just about one problem. Keep cruising. Part A on this one. Log base 3 of x is equal to a negative 3. And they want to solve for x. Okay. So how do I solve for x on something kind of like this? Well, I'm going to do my friends again. So I got a base of 3 right there. Top of the tower, off the island. 3 and x were good friends, but you have exceeded my limits. Excuse yourself. Moving on. Negative 3 was all by himself. So, there you go. I don't like to put the arrows very often because it's not switching. It's not crossing. It's not falling. There's a lot of arrows that could happen. I'm not talking arrows. I'm talking friends. I always keep talking about my friends, okay? That's the easiest way that will always be consistent, okay? Because if I rewrote this, I just want to decide, what if I had rewritten it like this? And so my answer, again, 3 to the negative 3 equals x, right? We already did that. But notice here, they just fall. They fall instead of cross. Don't do falls and crosses. We're not doing arrows. We're doing friends. I'm just showing you where they went. So sometimes I probably ought to just not do it at all. 3 cubed is 27 because it has a negative power. It's going to be a fraction. So there you go. Part B. Log base 5 of 25 equals x. You could probably get this without thinking too much, but I'm thinking, like, here's your English. I'm saying 5 to what power equals 25. That's what that statement says in English. 5 to what power equals 25. 5 to the x is equal to 25. And we could do the friends if you want. It's the same thing. Well, it's 5 squared is equal to 25. That is, if I can get a cool looking 5 there. So then x equals 2. There you go. Keep cruising. 43046. So part A here says I got log of 60. And they want to know what this decimal equivalent is in the calculator. You have a log button on pretty much any calculator that you should have. A scientific, graphing, whatever. Desmos, doesn't matter. Your phone even should have some of this stuff, I'm pretty sure. Normally when we use a calculator app, we do our vertical portrait position, if you kind of understand how the phones work. But if you turn your phone into landscape mode sideways, so it's longer, not taller, it should expand your calculator app into a scientific calculator, and you would have all these other special log buttons and stuff. So same thing here. Do it in some kind of calculator. I'm just saying, if you don't have a calculator, you don't know what Desmos is, everyone that's got a phone, do it somehow, some way, and you get this guy here. And that's it. There's others, of course. There's only part A. If they say ln of 70, you just put it in the calculator. You got an ln button. You're good to go. Okay. Now, if they're going to say log base 2 of 70 and find it out, that's a little different. Now, I'd say most of the graphing calculators have an ability to put in a log base something or other, even if it looks ugly. There is an ability to do that. I'm just going to go and tell you the quick formula for something like this. Let's just say this is just an example that I was thinking of as we were talking. You can rewrite this as log of 70 divided by log of 2. And then you can use your calculator, any calculator, to get that. Notice that logs are not going to cancel. Like if you were to type this out longwise, it looks just like this. So many times I've seen people just ignore the log and say, oh, this whole thing divided by 2. Nope, that's not how it works. You got to have log of this, log of that. Also, remember, you got to close your parentheses. Otherwise, it starts thinking there's lots of stuff going on there. And you would get an answer. Let me go ahead and do that answer just so, if you're practicing with me, I could tell you, if you get it right or wrong. 6 point, if I could write a 6, that is. 6.12928, whatever. So if you're doing that and you get that answer, then you're doing it correctly. So that's good. And this works for any numbers. It doesn't have to be 2 and 70. I'm just kind of showing you an example, just in case that comes up on the homework, let's say, or who knows what. For 3053, they have y equals log base A, don't like A's, base A, and they're wanting you to find out what that is, so your y equals a function of some kind, given that we have a graph where it does this. I'm going to cross at 1, which I'm telling you is not very helpful because all logs cross at 1, unless you're shifting them. And then we have another point over here at 5, 1. So that's good. Let's use that 5, 1. I think my comma doesn't look very good there. There we go. 5, 1. Again, this is an x, this is a y, and we got a y and we got an x. So I'm going to put these two together, and so I got a 1 equals log base A of 5. And you're thinking, wow, great, I don't know what to do now. I don't either. What do we do? Well, we're going to do the friends. Base A, top of the tower, off the island. A and 5 were good friends, no longer. You're out of here, bro. 1 was all by himself. Well, 1 and A now are friends. So you're saying A to the 1 power is equal to 5. Guess what? Well, that's it. A equals 5. So now you can go back and write your answer here as log base 5 of x. That's what they want for that answer. Okay. I have 3 more problems, and they're all a little different. I don't want to do the same problem again and again, obviously. F of x is equal to log base 6 of 6 minus 2x. Okay. What they're wanting here is the domain. What's the domain of this guy? So what I often have to do is I say, well, let's find the inside and set it equal to 0. This guy right there. So I got 6 minus 2x is equal to 0. Solve for x. Divide by the 2. 3. What 3 is kind of like a start point, similar to what you would have with a square root. It could also be an end point, just like with square roots, and think it is because of that negative sign right there in the front of the x. But the last thing is that because this is a log, we don't use the square braces. Do you have a square root? No. So you don't use square braces. See, square root, square braces. We don't have either of those. So you're going to use parentheses on this log. Okay? So parentheses are always with the logs. I basically what I'm trying to paint a picture of is that normally we would just say something like, well, 3 to infinity, use some parentheses, call it a day. But that's not the answer here, just because, again, I have a negative in front of the x. What the true answer is here is this guy. Now, I want to do this more systematically with you instead of kind of just like, winging it, I guess you can say. Blah, blah, blah. You can ignore all this. Basically, inside equals 0. This is my critical point. And I want to find out what the intervals would be around, literally like going around the 3. So let's say we got 3 right there. Well, this interval over here, we got negative infinity to 3, 3 to infinity. My intervals would look like this. And what I want to do is test them. I want to test them with a particular number that is easy inside of the interval. So I'm going to test a 0 because 0 is inside of that interval, and 4. That's a pretty easy number as well. So I'm going to test those numbers in the original and see what we get. So log base 6 of, and I got 6 minus 2 times 0. Log base 6 of 6. We've already seen this. They actually cancel, leaving a 1, in fact, because that's a 1 power right there, technically. It's the invisible 1. Keeps showing up. Is this an answer? Is this a real number? Is this something that we get, like a good result? Yes. Could I put that in a calculator? Yes. Log base 6. 6 minus 2 times the 4. Notice here, I got log base 6 of negative 8. Now, I'm sorry. That's a negative 8. 6 minus a negative 8 is negative 2. Okay, cool. I still have a negative, though. I got log of a negative, and that's confusing me. If you want to test this in the calculator, I don't really care about the base 6 so much. Just log negative 2. What do you get? You get error, undefined. And basically, it just doesn't work. So this guy doesn't work. This guy works. Therefore, that is your answer, the end. That's the very long way. And that's why I do shortcuts. Start, end points, all that kind of stuff. I talk about it, thinking about it, to make it quicker. The long way is perfectly fine as well. It's just a different way to do it. And I'm glad I showed you both. Continuing on, I got A is equal to negative 8, 2, 6, 7 ln of d over d naught. That's kind of weird. D naught. There you go. This is how you know how to spell it correctly. D naught has a little 0 subscript there, basically. A little 0 subscript. D naught's initial. D is, final. And so we saw this back with A and A naught in the previous section. Here in this particular case, we're talking about 83% of the original amount is going on. If I could spell original, that would be helpful. Go. Figure out what my final amount is. In fact, because this is a ratio of d over d naught, I'm just plugging that in for the entirety of that fraction. Sounds kind of weird, doesn't it? But I'm actually, for that fraction, that ratio, I'm putting in a ratio. It's technically a ratio, a fraction of some kind. I plug it all in, use the calculator, and I got a 1540.386. And there you go. I think it's a word problem of some kind, but I'm not too concerned about it. 43098. The last one. Again, I'm pretty sure this is a word problem, but I'm just trying to get down to the core of it. So 4 times, and then we got a fraction here, log of n over 10 divided by log of 2. And they say find t given that n is equal to 2 million. Almost ran out of room. 2 million. Find t. Well, there's my t. Basically, all I'm doing is plugging in the 2 million right there. I'm not kidding you. That's all it is. 4 times, and I got log of 2 million divided by the 10, and then divided by log of 2. Like, I just put it in the calculator, just like that. All at once, and I got 70.438 5, 6. And there you go. And that's all I got for this section. So, if you have any questions, you let me know. Thank you very much. Have a great day.